Hello there, I'm recording this video for the Module 2 test. This is problem number 11. We're taking it to 11. Okay, so we're told that a 1.50 kilogram object has a certain specific heat of 0.4521 joules per gram degrees Celsius. And at 110 degrees Celsius, it releases 5,505 joules of heat. What is the new temperature? Okay. So the most important thing to remember here, okay, is that if it's releasing that heat, then the Q is going to be a negative number, okay? So the Q, here's our formula. Q equals MC delta T, okay? So we're told that the Q is a negative number and that Q is 5,000. It's negative 5,505 joules, okay? The mass is 1.50 kilograms. We're going to convert that to grams by multiplying by 1,000. We say 1,500 grams, okay? And we're told the C. What we need to calculate is not just the delta T, but then the new temperature, the final temperature. So we're told delta T is the final temperature minus the initial temperature, and we're told the initial temperature is 110 degrees, 0.0 degrees Celsius, 110.0 degrees Celsius. So this is all the information that we know. So now we're going to begin to calculate. So we know everything except for delta T. So we're going to set it up in terms of delta T. Delta T is Q divided by M times C. Now the Q is a negative number, negative 5,505 joules. The M is 1,500 grams. The C, I didn't write it down, but it's on the test, is 0.4521 joules per gram degrees Celsius. I'm going to set up my units, end up with degrees Celsius. So I'm going to calculate all this on my handy calculator. Clear. Okay, so negative 5,505 divided by, open parentheses, 1,500 times 0.4521, close parentheses, equals, we get negative 8.1176. Okay, so here I have 1, 2, 3 significant digits. Here I have 4, here I have 4, so I only want 3 in my answer. 1, 2, 3, we're going to round this to negative 8.12. So the delta T is a negative 8.12 degrees Celsius. We are missing this piece of information, the final temperature. So T final, I'm going to rearrange this algebraically. I'm going to say T final is going to be equal to delta T plus the initial temperature. Okay? So that is negative 8.12 plus 110.0 degrees Celsius. Okay? So let's do that. 110 minus 8.12. It's 8.101. Okay, so it's 101.88. But again, be careful with our answer, and we have to go back here and we have to look at our precision. So this is precise to hundredths. This is only precise to tenths. So I want this answer to be precise to tenths. So I'm going to say that my T final, my final temperature will be 101 degrees and 9/10 of a degree Celsius. Okay? So that's the final answer, 101.9 degrees Celsius. Let me know if you have any questions about this or any other of these problems.